The National Electrical Code, specifically Section 300.3c, addresses the use of conductors in raceways. It states that conductors shall not be installed in raceways unless they are contained within cables or installed as bare conductors in raceways identified for such use. This means that bare conductors are permitted under certain conditions. Now let's examine the specifics for various conduit types. Firstly, electrical metallic tubing or EMT. EMT is permitted to contain a bare conductor if the conduit is over 6 feet in length and is threaded at both ends. This is a crucial requirement to ensure proper grounding and bonding. Secondly, polyvinyl chloride or PVC conduit. Similar to EMT, PVC conduit is permitted to house a bare conductor if the conduit is over 6 feet in length and is threaded at both ends. This requirement helps maintain electrical safety and integrity within the system. Thirdly, liquid-type flexible metal conduit or LFMC. LFMC is permitted to contain a bare conductor if the raceway is specifically identified for such use by the manufacturer. Always consult the manufacturer's specifications to confirm this suitability. Fourthly, liquid-type flexible non-metallic conduit or LFNC. Similar to LFMC, LFNC is permitted to contain a bare conductor if the raceway is identified for the use of bare conductors. Again, verify the manufacturer's instructions to ensure compliance. It is worth noting that NYPD is not a raceway type recognized by the National Electrical Code. Therefore, it's not relevant in this context. In addition to conduit-specific rules, there are general location requirements for bare conductors. Bare conductors must be used in accordance with the manufacturer's instructions. They must not be smaller than number 8 American wire-gauge copper. They must be equipped with fittings designed specifically for bare conductors. They must be secured at each end and at intervals not exceeding 10 feet. And they must be protected from physical damage and the elements. To reiterate, for EMT and PVC, the conduit must be over 6 feet in length and threaded at both ends to be suitable for a bare conductor. For LFNC and LFNC, the raceway must be identified by the manufacturer for the use of bare conductors. Always consult the relevant sections of the National Electrical Code and the manufacturer's specifications for detailed guidance on installing bare conductors in raceways. The information provided is based on the 2017 National Electrical Code. Always refer to the most current edition of the National Electrical Code and local amendments for the most accurate and up-to-date requirements. In summary, the National Electrical Code allows bare conductors in specific raceway types under certain conditions. These conditions include the length and threading of EMT and PVC conduits, as well as the manufacturer's identification for LFMC and LFNC. Additionally, general location requirements apply to all bare conductor installations, focusing on conductor size, fitting types, securement, and protection from damage. Understanding these rules is essential for ensuring electrical safety and code compliance. Keep in mind that local codes may have additional requirements or restrictions, so it's always a good practice to consult with local electrical inspectors and authorities. Now let's delve a bit deeper into the practical considerations of using bare conductors. When installing a bare conductor in a raceway, it's crucial to ensure that the conductor is properly sized for the intended application. The National Electrical Code provides guidelines for conductor ampacity based on the conductor's insulation type and the ambient temperature. However, since a bare conductor lacks insulation, its ampacity may differ from that of an insulated conductor of the same size. Consult the National Electrical Code tables for bare conductor ampacity ratings, taking into account the specific conditions of the installation. Proper termination of the bare conductor is also essential. Use connectors and fittings specifically designed for bare conductors to ensure a secure and reliable connection. These fittings should be compatible with the conductor material and the raceway type. Also, consider the environmental conditions when selecting fittings. In corrosive environments, use corrosion-resistant fittings to prevent degradation of the connection. Another important aspect is to protect the bare conductor from physical damage. Ensure that the raceway provides adequate protection against impact, abrasion, and other forms of physical stress. If the raceway is exposed to potential damage, consider using a heavier-duty raceway type or providing additional protection, such as a guard or barrier. Furthermore, pay attention to the routing of the raceway. Avoid sharp bends or kinks that could damage the conductor or the raceway. Use appropriate bending tools and techniques to create smooth, gradual bends. Also, ensure that the raceway is properly supported to prevent sagging or displacement. In addition to the National Electrical Code requirements, consider industry best practices when installing bare conductors. These practices may include using a conductor lubricant to facilitate pulling the conductor through the raceway, grounding and bonding the raceway at appropriate intervals, and performing a thorough inspection of the installation after completion. Remember that electrical work can be dangerous and is essential to follow all safety precautions. To energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. By following the National Electrical Code requirements, industry best practices, and safety precautions, you can ensure that bare conductors are installed safely and effectively in raceways. This will help maintain the integrity of the electrical system and protect against potential hazards. Keep in mind that the information provided here is for general guidance only, and is not a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for specific recommendations based on your particular situation. The importance of proper grounding and bonding cannot be overstated. Grounding provides a path for fault current to flow back to the source, which helps to trip over current protection devices such as circuit breakers and fuses. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, which reduces the risk of electric shock. When installing a bare grounding conductor in a raceway, it's crucial to ensure that the raceway itself is also properly grounded and bonded. This can be achieved by using grounding bushings, bonding jumpers, and other approved methods. Consult the National Electrical Code for detailed requirements on grounding and bonding raceways. In some cases, it may be necessary to use a separate grounding conductor in addition to the bare grounding conductor in the raceway. This is particularly important in situations where the raceway is not a reliable grounding path, such as when it's made of non-conductive material or when it has multiple joints. Also, consider the size of the grounding conductor. The National Electrical Code specifies minimum grounding conductor sizes based on the size of the overcurrent protection device protecting the circuit. Ensure that the grounding conductor is large enough to safely carry the maximum fault current. Another important consideration is the type of grounding electrode used. The National Electrical Code recognizes several types of grounding electrodes, including ground rods, ground plates, and metal water pipes. The choice of grounding electrode depends on the soil conditions and other factors. Ensure that the grounding electrode is properly installed and connected to the grounding system. In addition to grounding, bonding is also essential for electrical safety. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, which reduces the risk of electric shock. This includes metal raceways, metal enclosures, metal equipment, and metal piping systems. Bonding can be achieved by using bonding jumpers, bonding bushings, and other approved methods. Ensure that all bonding connections are secure and reliable. Also, consider the material compatibility of the bonding connections. Use connectors and fittings that are compatible with the materials being bonded to prevent corrosion. In summary, proper grounding and bonding are essential for electrical safety. When installing a bare grounding conductor in a raceway, it's crucial to ensure that the raceway itself is also properly grounded and bonded. This can be achieved by using grounding bushings, bonding jumpers, and other approved methods. Also, consider the size of the grounding conductor, the type of grounding electrode, and the material compatibility of the bonding connections. By following the National Electrical Code requirements and industry best practices, you can ensure that the electrical system is properly grounded and bonded, which will help protect against electrical hazards. Always remember that electrical work should only be performed by qualified individuals who are familiar with the National Electrical Code and local regulations. Improperly installed electrical systems can be dangerous and can lead to serious injury or death. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical engineer. The National Electrical Code is a complex document, and it's essential to stay up to date with the latest revisions. The National Fire Protection Association (NFPA) publishes the National Electrical Code every 3 years. It's also important to be aware of any local amendments to the National Electrical Code. Local jurisdictions may have additional requirements or restrictions that must be followed. To ensure compliance with the National Electrical Code, it's a good practice to attend continuing education courses and seminars. These courses can help you stay up to date with the latest changes and best practices. Also, consider becoming a certified electrician. Certification demonstrates that you have the knowledge and skills necessary to perform electrical work safely and effectively. In addition to the National Electrical Code, there are other standards and regulations that may apply to electrical installations. These include standards from organizations such as Underwriters Laboratories, the Institute of Electrical and Electronics Engineers (IEE), and the American National Standards Institute (ANSI). It's important to be familiar with these standards and regulations to ensure that your electrical installations are safe and compliant. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. This includes homeowners, contractors, and electrical inspectors. By working together, we can create a safer electrical environment for everyone. If you see something that doesn't look right, report it to the appropriate authorities. Don't try to fix electrical problems yourself unless you're qualified to do so. Remember, electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. In conclusion, the use of bare conductors in raceways is governed by specific requirements in the National Electrical Code. Understanding these requirements is essential for ensuring electrical safety and code compliance. Always consult the National Electrical Code and local regulations for the most up-to-date information. If you have any questions or concerns, consult with a qualified electrician or electrical engineer. By following these guidelines, you can help prevent electrical accidents and create a safer electrical environment for everyone. The information provided here is for educational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for specific recommendations based on your particular situation. Keep safety as your top priority when working with electricity.